This is just a quick demo. We'll do some live demos here very shortly, but this is working interactively to slice and dice 10 million rows right in your browser. So we'll talk about how we can get data visualization to be at the exact speed of interaction that you want. Buttery smooth, 200 frames per second, all in the browser, even if you've got millions of rows of data that you want to explore. Hey, I'm Alex. Thank you so much for the intro. My background is industrial systems, but I really like this data stuff a lot more. And I've gradually been getting more and more into Duck-themed databases over time. First with the open source project DuckDB with DuckDB Labs, did some documentation for them. And then now I work at MotherDuck for the last 2.5 years. And MotherDuck is a cloud data warehouse built on top of DuckDB. So we're going head to head with the big guys, Snowflake, Redshift, BigQuery. But if you've got less than a petabyte of data, we think we can be faster and cheaper. So we're pretty excited. But today we're talking all about how do we explore data at the speed of thought right in your browser. So we all know that it can be pretty painful a lot of the time. And today I'm going to make fun of Expedia. So I occasionally have to use Expedia still, and that's what it feels like. It feels like I have to use it. So I'm going to pick a couple of places that I want to go to. I'm going to go ahead and hit search, and then I'm going to wait for the server. And as a user, this is kind of expected, right? There's a contract I have with this type of site where, okay, when I click search, it's going to take a moment. It's going to find me the deals and take a little while and get the data back. But the very first thing I'm going to do when I get to this UI, which is definitely not cluttered, is I'm immediately going to click on nonstop. Because if there's a single nonstop flight, I'm not going to do a changeover in any airport. I'm going to fly direct. But then I got to wait again. I thought I already talked to the server. Why do I need to talk to it again? I should have everything I need to be exploring interactively, but I have to wait just as long as the first time I got to this page. And I'm going to do that again for a bunch of different filters. I might even be dragging some sliders for like times of day that I'm going to be trying to depart or arrive. And every time I do it, I have to sit there and I have to wait over and over again, and just gradually makes me hate Expedia. So in 2026, interacting with data should feel instant. Our laptops are incredibly fast. The internet, our network speeds are incredibly fast. Why does the internet still feel slow? It's because we're doing too much back and forth. So that's what we want. What kinds of things does it take to get there? Well, yes, I want things to be fast. I want things to be instant, but I also don't want to have it take forever for me to develop something like that. And this should be a common problem. When I'm working with a lot of data, it doesn't have to be domain specific. We don't need a specific library for airline flight data, right? We need a data interaction library. We should be able to grab it off the shelf. And we want it browser side. When you go back and forth to the server, it takes too much time. That's enough time to make it not feel interactive anymore, where I am not able to make my decisions as fast as I want. And then what if I go viral? If I have everything heavily dependent on a server, my server is either going to crash or it's going to auto scale to the moon, and I'll be out quite a lot of money. So how can I handle this even if I go viral? And then lastly, we got to do this for a whole lot of data. Data sizes are growing over time. We want to be able to handle millions of rows without a problem. So let's do some demos. All right, so here we are looking at 5 million rows of data of the Milky Way galaxy. So this is from the Gaia telescope. And this is, spectral readings looking at the Milky Way, kind of looking at it flat across the disk here. And this is a framework called Mosaic. It's open source, coming from the University of Washington. They're kind of interactive research lab. And it allows us to interact with the data at the speed of thought, where I can explore what is this odd object here off to the side of the Milky Way. And that has a really interesting spectra. Maybe I can look and see how things are doing in Coruscant, in the core. And maybe take a look at Tatooine, Dantooine, way out in the Outer Rim territories. But I'm able to do that and cross-filter across 5 million rows of data, buttery smooth, right in the browser. And what does it take to do that? What does the code look like? Well, there's a couple ways we can build it. We can build it imperatively in JavaScript, so we can loop through and build it up through some nested functions. Or I can just use a YAML spec or a JSON spec. And the nice thing about the JSON spec is there's a JSON schema document. And so Claude can help us. We already know the range of options that are accepted, so Claude can help us build these interactive visuals. But I'd start off by importing. I actually can write a SQL statement if I choose here, or I can just pull from a file on the internet, from S3, for example, or anywhere on GitHub. And then I'm going to specify kind of how am I going to do my cross-filtering. And then I'm going to pass that through to the parameter that I want it to filter on. Is I basically each chart, I want to be filtering on that interactive brush. And so just that kind of construction of that filter and kind of placing that filter in each of the different charts that we're generating allows us to have that rich interactivity on that large data set. So really a pretty out-of-the-box experience to get that kind of interaction. We can do the same thing with the visual that we were looking at the beginning. And this is 10 million rows of data with airline flights. And so unfortunately, we're all very familiar with airline flights being late. So what's true about the flights that are latest? Well, they all take off late in the evening. So even if you get back to somewhere, somewhere around 4 p.m. is really where things start to go south and where you're really going to start to have things be really late. And we can also see that by looking at it the same way here. If you take off early, much less likely to be delayed. If you take off late at night, watch out. We can do the same thing with things that are not just traditional charts and graphs. You can do it with spatial diagrams as well. And like how we saw the, kind of heat map plot for looking through the galaxy. So this is taxi data, which is a, well-established data set, but you can look at, pickups and see where people get dropped off from where they get picked up. So you can kind of explore this at interactive speed, and it all re-renders incredibly quickly. So behind the scenes, what is happening here? So when I flip to a particular example, and I'm changing examples here just so that we can see kind of the code off to the side. This is actually using a little bit of MotherDuck in there, but again, the other pieces were just directly with DuckDB. So in this case, you can see when it first loads, it did run a couple of SQL statements. And if you think about it, charts and graphs are aggregations. They are summarizations. They're filters. Those could look like SQL operations, and that's what we're doing in Mosaic. Each time that I go ahead and do a hover over, it actually will start doing what's called a data cube index on my data. And it's actually going to pre-calculate a little bit about the interactions that are coming next. So this is part of how you get things to be fast, is you calculate things ahead of time. And so because of that, now I'm able to interactively look around, but you can just see that every time I move by a single pixel, it's actually running another SQL statement in the browser. And you can see the request time, that's in milliseconds. So here we're about 5 milliseconds or so. That's our 200 frames per second that we talked about at the beginning. So that was our demo. That's taking a look at what does it feel like to have that kind of buttery smooth, rich interactivity directly in your app. How did that work? We've got our Mosaic charts. They're using a library called VGPlot, and they're declarative. That's what gives us that superpower of allowing it to be a JSON spec and allow Claude to help us. So it's really nice that we don't have to kind of build up our charts like D3 level of really building block by building block. We can kind of just ask for a chart and receive one. As we do a selection event, that gets sent to the Mosaic coordinator. And the Mosaic coordinator interfaces with our database. And it looks at what you're slicing and dicing and writes a SQL query for you. So you don't have to write any SQL with this. It's going to do that on your behalf. And we'll talk about how it's actually a pretty fancy SQL that it's writing to do a lot less work. From there, it actually talks to a database that lives directly in your browser. And so it's inside a local web worker. So it's on a separate worker thread. So it's not interfering with your DOM manipulation or slowing down your app. It's working in the background, and it's using DuckDB WASM. So we'll talk about DuckDB in a minute. This is compiled to WebAssembly, so that way it runs in that browser sandbox and is quite quick. Where do we get the data from? We're not actually getting it from a server that we operate. We don't want to bottleneck that in case we go viral, right? So it's actually really an entirely serverless setup. You can do this on a statically hosted site. And what you'll do instead is you'll go talk to AWS S3, or in our case, Cloudflare R2, which is just an object store. You can store anything you want there. But the magic of R2 is that there are 0 egress fees. So if you get to be number 1 on Hacker News, it won't cost you a dime. And in our case, we're storing the data as Parquet files. Parquet, who's heard of Parquet? Anybody? Hey, a couple Parquet folks, that's great. Parquet is a format that's been around about 10 years. But when you need it, you need it. And it's a columnar file format, which means that it can store millions of rows of data much smaller than a JSON file or even a gzip JSON file, because it can compress a lot better. And once we've pulled that Parquet file down into DuckDB WASM, then we'll go ahead and return it back to our front end with Apache Arrow. Who's heard of Apache Arrow? Oh, sweet. Today you guys get to hear about Apache Arrow. It is kind of the industry standard in-memory format for columnar data. And so when you're sending data across processes with IPC or sending it over the web with HTTP, you can send it column by column and again, get a much better compression ratio than sending it as JSON. And it also is self-describing. So it includes the data types. And so you're not converting back and forth from strings. You can actually keep it as, integers or floats or what have you. So we mentioned it briefly, but what is DuckDB? DuckDB is an in-process database. Anyone know of any other databases that are in process? Shout it out. SQLite, that's the one. There's a few more, there's lots more. But SQLite is, by many metrics, the most popular database on the planet. There are 1 trillion SQLites out there. They're in planes, they're in space, they're in every phone, every browser. And so in process doesn't feel like a typical database, but that's actually what a typical database is. It's actually in process because SQLite is so common. So DuckDB is different than SQLite because it's designed for analytics. So if you actually want to aggregate 1 million rows of data, DuckDB is going to be 100 times faster than SQLite. But if you want to grab 1 row, SQLite is going to be faster for that. So it really is choosing the right one for the workload. DuckDB is MIT licensed. You can use it for anything that you want. We've got clients in 15 to 20 languages. Most popular one is Python, but we also have a Node client as well as a WASM client. What is the secret sauce we talked about of the fancy SQL that Mosaic is writing on our behalf? And these are some tips that we can use in other ways. They don't have to be Mosaic specific, but really useful if you have a lot of data you're working with in the browser. And the first one is you don't want to plot every point. If you have a time series and you've got 1 million points, don't ask the browser to do all that work. Choose the number of points to plot based on how many pixels you're actually showing. And this is using an algorithm called the M4 algorithm. It sounds really fancy. It's pick the min X, min Y, and the max X and max Y. So 4 M's, M4, very fancy. But the idea is within a pixel, those are the things that are going to define how you connect to the pixels around you. And that's all you need to have a completely visually accurate representation of your data at a much smaller compression. And what we actually do with Mosaic is we actually do this calculation where we grab those values all the way in the database. So we don't ask the browser to do that either. We're doing that in the web worker asynchronously inside of DuckDB WASM. The next piece of secret sauce is that we're pre-cubing. We're doing this on a hover event, which is a very high intent action of you're about to filter. So we're doing it just in time. And cubing was kind of all the rage in the 90s in data analysis with like MDX cubes and SSAS if you're a SQL Server person, like I used to be. And that had a lot of weaknesses. You'd kind of run your cube overnight and it would chug around for an hour and it would come up with every combination of things you could possibly think of to slice and dice by. But we're doing on-the-fly cubing. We know the charts that we want to see and we know the pixels that we actually want to render on. So we can cube to the exact pixel sizes that we want and the exact dimensions we actually are slicing and dicing by. And this allows us to do it very, very quickly and have it be nice and compressed. And again, this is happening in the database. So when we say it's a cube, what that really is just a table in the database. And we pre-calculate it to the exact level of aggregation that we want to show on the visual. And this is actually in relationship between the visuals. So this is cubing the combinations of what you could slice and dice between the charts. And that's why the interactions are so quick to update across them. We actually pre-calculate how they interact with each other. Lastly, the other secret ingredient is that DuckDB WASM is really, really fast. So the database community's favorite benchmark for analytics is TPCH. It's kind of the old standard. The scale factor is 0.5 in this example. It's about 30 million rows. And it's about 170 megabytes if you use that nice compressed Parquet format. And if you want to query that with any of those benchmark queries, on average, it takes about 73 milliseconds to do that in your browser. That's faster than you can talk to a server. And it's free. And it's 100% scalable because every user going to your site has a browser. So it scales perfectly whenever you go to Hacker News. And if you did it in pure JavaScript, the benchmark is old. It's from, I want to say 2003, but at the time it was between 10 and 20 times faster than doing it in even some libraries that were written in JavaScript for data manipulation. DuckDB is C++. It's vectorized. It uses SIMD, a lot of really advanced topics where compiling that to WASM, you just get a lot of speed for free, whereas JavaScript and V8 just has a harder job in front of it to try and keep up. The other thing is we are downloading more data this way, right? We in this case, you'd be downloading 170 megabytes of data. While that's not nothing, turns out networks are fast now. A gigabit Ethernet is going to download that in 1.5 seconds. And that's probably faster than Expedia can show me that, page of whatever it is, right? And we just grabbed 30 million rows in that amount of time. On even T-Mobile, which is the fastest 5G network right now, that's about 300 megabits per second. You can get it in under 5 seconds. And so that's something you could maybe bake into your app earlier in the flow when someone's logging in, when someone goes to the analytics page. You can front load and preload that data download. So by the time the user has that high intent of wanting to actually filter, it's already done. So in conclusion, the fastest way to render data is to not render it. Use pixel-aware plotting techniques like M4 and others to only render at the resolution that you're actually working at. The fastest way to aggregate data is don't do it on the fly. Pre-aggregate it. Do it a little bit ahead of time so that way it's not in the way of their flow. And then lastly, friends don't let friends crunch millions of rows of data in the browser in JavaScript. Use DuckDB WASM instead. And that is what I had for you. So thank you so much for your time and attention.